Hey guys, welcome back to Math with Morgan. In today's video, we're going to be looking at prime factorization, finding the highest common factor and the least common multiple. So, the objectives of this video tutorial is for you to learn how to write a number as a product of its prime factors and to learn how to find the highest common factor and least common multiples of numbers. Let's get started. We're going to start off with a recap, okay? For this, you need to know what primes, multiples, and factors are. If you already know what these are, I'm going to put timestamps in the comment section so that you can skip to prime factorization, the next part of the video. Okay, let's begin. So, first of all, factors are numbers that can divide a number in question without any remainders. For example, 3 can divide 12, so it is a factor of 12. Hence, the factors of 12 are 1, 2, 3, 4, 6, and 12. Keep in mind that factors would always come in pairs. So the factor pairs of 12 are 1 and 12, 2 and 6, and lastly 3 and 4. Okay. Multiples are all numbers found in the timetable of a specific number. For example, the multiples of 2 are simply 2, 4, 6, 8, and 10. It goes on and on. The last thing is prime numbers. Prime numbers are simply numbers that have only 2 factors, which are 1 and the number itself. For example, 2 has factors 1 and 2. Other prime numbers are 3, 5, and 7. Okay, with that said, let's get into the video. So prime factorization, we're going to start off with examples. So here, we're going to learn how to write a number as a product of its prime factor using a factor tree. For example, write 12 as a product of its prime factors. So we're going to write 12. But then we're going to break it down using a tree. 12 can be written as 3 times 4, so we put 3 and 4. 4 can be written as 2 times 2, so we write 2. So we break it down into 2 and 2. So whenever you reach a prime number, you end at that part of the tree. And now what we're going to do is circle up all the prime numbers in our tree. And then we get 12 equal to 2 squared. The little 2 at the top is the power to show that there are 2 2's in the tree. If you haven't watched my video on indices, please kindly check that out. I'll put it in the description or in the cards. Okay, so this is 2 squared times 3. Let's take a look at another example. Prime factorize the number 84. So again, we start with 84. We break it down into 2 numbers, 2 and 42. I always like to go with the smallest number possible. So I start by dividing 84 by 2 because it's the smallest number that can divide 84. Okay, so 42 can also be broken down again into 6 and 7. Keep in mind you can have different numbers than I do. It doesn't really matter. You would always get the same answer. Okay, now 7 is a prime number, 6 is not, so we need to break down 6 into 2 parts again. That gives us 2 times 3. Okay, all of these numbers at the end of the tree are prime numbers, so we're just going to circle them all up. And this is what we'll use to write 84 as a product of its prime factors. So since we have 2 2's, we're going to have 84 equal to 2 squared times 3 times 7. Okay, let's look at more examples. Write 45 as a product of its prime. 45 can be broken down into 5 times 9, and 9 will be broken down into 3 times 3. Again, we have the prime numbers and we circle them all up, and we have 45 equal to 3 squared times 5. One last example, which is a bit much harder. We have to prime factorize 525. So looking at the number, we can definitely tell it's divisible by 5. So I'm just going to start by dividing it by 5 to break it down. So we'll have 5, and on the other side we have 105. I can break this up again into 2 by writing it as 15 times 7. Then I break down 15 again into 3 times 5. Okay, again, we circle up all our prime numbers and we use those to get our answers. Okay then, let's take a look at highest common factor and how we can use our knowledge of prime factorization to get highest common factor. Okay, the highest common factor of two or more numbers is the greatest number that can divide both numbers with no remainder. It can be derived by using the factor tree and prime factorizing each number. Taking a look at the first example, find the highest common factor of 12 and 84. Well, 12 was written as 2 squared times 3, and 84 was written as 2 squared times 3 times 7. Those were the previous examples we did. So now what we're going to do is write these numbers in expanded form like so. Then we'll have to find what they share in common. Okay, after writing them expanded form, they share a 2 in common, another 2 in common, and a 3 in common. So since these are the numbers they share in common, we're just going to go ahead and multiply what we've got to get is highest common factor. 2 times 2 times 3 is simply going to be 12. So the HCF is 12. Okay, let's take a look at more examples. Find the highest common factor of 45 and 525. In the previous parts of this video, we've already prime factorized 45 and 525. So we're going to write them down. 45 was equal to 3 squared times 5, but then we're going to expand that a little bit so that it becomes 45 equals 3 times 3 times 5, and then 525 is 3 times 5 times 5 times 7. Let's get what they share in common. Well, they have a 3 in common. They also have a 5 in common. And that's it. So we multiply 3 by 5 and we would see that the HCF is 15. Alright then, let's look at least common multiple. Now, what is the least common multiple? The least common multiple of two or more numbers is the smallest number that is evenly divisible by all the numbers in that set. It'll be easier to understand with an example. So it can also be derived by using the factor tree and prime factorizing each number. Let's say we wanted to find the LCM of 24 and 36. So we'll start by prime factorizing. Okay, so 24 can be written as 2 cubed times 3, and 42 can be written as 2 times 4 times 3 times 7. Excuse me. Alright then. In this case, we write them in expanded form and we get what they share in common again. We have a 2 and a 3. But also we need to get the rest of the numbers that they didn't share in common, which are the ones circled in yellow. We're also going to make use of these numbers by multiplying all of them with the ones that they had in common. So we have to do 2 times 3 times 2 times 2 times 7. Unlike H.C.F, where we were taking just the numbers they shared in common, in L.C.M, we get the numbers they share in common and we also take the leftover numbers and multiply to it. Okay, in this case, when we multiply all of these numbers, you would see that the LCM is 168. So 168 can be divided by 24 and 36 evenly. Okay, let's take a look at some practice questions. Given A equals to 2 cubed times 3 times 5 and B equal to 2 squared times 3 times 5 squared, write down the HCF of A and B. Okay, keep in mind that we're going to get just the numbers they share in common. It's highest common factor. So we write A in expanded form and we write B in expanded form. We get the numbers that they share in common. We have a 2, another 2, and a 3, and also a 5. So now we just multiply all these numbers together and we get the HCF as 60. Find the lowest common multiple of 40 and 56. So again, we need to prime factorize each of these numbers. I'm just going to insert the factor trees of 40 right here and 56 right here. Then we get the numbers that they share in common. So 40 can be written as 2 times 2 times 2 times 5, and 56 can be written as that. The numbers they share in common will be 2 and another 2. And the ones they don't share in common, which are the ones in the yellow circles, would also be multiplied to them. So what we do is we do 2 times 2 times 2 times 5 times 13. And that will be 520. Okay. Buses to Acton leave a bus station every 24 minutes, while buses to Barton leave the same bus station every 20 minutes. 2 separate buses to Acton and Barton both leave the bus station at 9 a.m. When will a bus to Acton and a bus to Barton next leave the bus station at the same time? So, we need to find the least amount of time both buses will take before meeting each other again. Keep in mind, if we were to go by the common sense method, we would start by adding 24 to 24 to 24 to 20 and writing down the 24 times tables and the 20 times tables until they each match. But then why do that when you can simply just find the LCM of each of these numbers? 20 can be written as 2 times 2 times 5, and 24 can be written as 2 times 2 times 2 times 3 as seen on the screen. So we have the expanded form of each of these numbers. We get the numbers that they share in common again, and also the ones that they do not share in common, because we are looking for the least common multiple. Okay, now we're going to multiply these numbers, including the ones that they don't share in common, and we'll get our LCM as 120 minutes. So it's going to be exactly 2 hours later that the buses will meet again. So what we do is we take 2 and add to a 9, and we get 11 a.m. So the buses will both meet each other again at 11 a.m. Okay, let's take a look at more practice questions. Martin thinks of 2 numbers. He says the highest common factor of my 2 numbers is 6, and the least common multiple of my 2 numbers is a multiple of 42. Write down 2 possible numbers Martin is thinking of. So let's let the 2 numbers be A and B. If they have a highest common factor of 6, it means both of them share 6 in common, and 6 can be written as 2 times 3. So both of them will be in common like this. And if they have a least common multiple of 42, it means that you would have to prime factorize 42 and take out 2 times 3. So in this case, this is the factor tree of 42, which is 2 times 3 times 7. It means that 7 has to belong to one of these numbers, either A or B. I'm just going to attach it to B right here. So this is another way to represent this, to look at how they both share 2 and 3 in common, and the 7 will be attached to another number. So A can possibly be 6 and B can possibly be 42. Okay, moving on. Light A flashes every 5 seconds. Light B flashes every 6 seconds. Light C flashes every 7 seconds. Work out how long it would take for all 3 lights to flash at the same time. So you want to find out the amount of time that will pass before they flash again. So what does that mean? We're looking for the least common multiple of time right here. So we go ahead and we prime factorize 6 and 5 and 7. But then 5 and 7 are all prime numbers. So we write this down and we try to find the least common multiple. Well, I guess none of them share the same number in common. So what we're going to go ahead and do is just multiply each of these numbers that they do not share in common. So that will be 1 times 5 times 2 times 3 times 7, and that will be 210 seconds. This is the amount of time that will pass before both of them flash again. Okay, let's take a look at another variation of questions. So John buys some pencils and some packets of pens for people to use at a conference. There are 27 pencils in a box and 15 pens in a packet. John gives 1 pencil and 1 pen to each person at a conference. He has no pens nor pencils left. How many boxes of each item did he buy to start with? Okay, so there are 27 pens in 1 box, and there's 15 pens in 1 packet. If he is sharing each person 1 pen and 1 pencil, it means he's possibly getting a multiple of 27 and a multiple of 15 in such a way that by the time he's done sharing them, they will all have equal amount of pencils and pens. So we need to also find the least common multiple of pencils and pens. Okay, so let's say he shares 2 boxes of pens. That would equal to 54, and 2 packets of pencils would equal to 30. This could go on and on, as we could have 3 boxes of pens as 81 and 3 packets of pencils as 45. So now what do? We write 27 as a product of its prime factors, which is quite easy to do, and 15 as a product of its prime factors as well. Then we get the LCM. So we get what they share in common, which is 3, and what they don't share in common is 3, 3, and 5. So we multiply 3 by 5 by 3 by 3. Okay, and that will give us 135. So now that means the number of pens and pencils he shared each were 135, but we want to know the amount of boxes of pens that he had to start off with. So we got to take 135 and divide by 27. So that's going to give us 5 boxes of pencils, and we do the same thing. We take 135 and divide by 15, and that will give us 9 packets of pens. Okay, if you like this video, please make sure to give me a thumbs up, and I'll see you in my next one.